All right, everyone. Thank you so much for joining us once again on Did You Know, the ESCO HVAC show. Now, we told you that every week we're going to bring top educators from the industry to help you get familiar and get comfortable with all of the technological transitions as well as refrigerant transitions. And if you haven't noticed, over the last few months, we've been spending a lot of time actually going out to technical training facilities, giving you a heads up on the training opportunities that are available for you. So, Eugene, Ty, and myself were invited to come down to this fantastic Fujitsu technical training facility in Addison, Texas. And the thing we have to think about as educators and as contractors and as technicians, we are all responsible for staying up to date with the changes in the industry, right? There's a lot of things happening that we all have our own responsibility to stay informed. You know, one of the things that we do as professionals is we take assessments to see what knowledge we have retained. And then we also go back for continuing education to make sure that we're staying up to date with what's happening. And that's really what we're here to do. So we are here to learn about the stages of VRF that may not have been comfortable with in the past. Because if we think about it from the classroom, if we have been out in the field for a period of time, like many of us have, and then we become educators, we get to the classroom, Eugene, and then what happens? Life changes, technology changes, right? And so we're all faced with, okay, how do we stay current? Well, you actually stay connected with this community that is just growing phenomenally. And we're so grateful to have you with us in the chat, whether you're joining us from LinkedIn, YouTube, Facebook, Instagram, from the HVACR Learning Network, put in the chat where you're joining us from. And if there's any questions that you have along the way, because we want you to be interactive with this, this community, this opportunity. So we're actually going to be doing a few different stages today. We're going to walk you through a variety of different applications. We're going to have some one-on-one conversations, and then we'll regroup at the end. So guys, thanks for joining us, and you'll get to introduce and talk to everyone as we go through. So I'm going to start the conversation out with Juan Perez. Juan, how are you, my friend?
I'm doing great. How about yourself?
I'm doing really good. So we've got to know each other very well in the last few days. Remember, this is our third day down here.
Yes.
So we've learned a lot of stuff. So this is actually going to be a recap of the things that we have learned all week, right?
Yes.
So let's think about like VRF from a big perspective.
Okay.
And if you go ahead and stay there, I'm going to get this camera to rezoom back to me here.
Yep.
There we go. Right. So we're learning about VRF, and let's grab a few slides and jump back to kind of a recap of the things we learned, right? This is one of the biggest questions we get as educators, right?
Yes.
Is, what is VRF? And so give us a fundamental, give us an overview of VRF.
So a VRF system, it's considered commercial right now. So it's
Right.
a barrier refrigerant flow system, right? It's refrigerant is controlled by target suction pressure and a target superheat and subcool. Right. So it's managing multiple indoor units, right? So you can go from 1 indoor unit to 64 indoor units.
Oh, wow. Yeah.
I'm not saying that VRF can't be residential either, because we do have smaller VRF units that work as heat pumps.
Yeah. Yeah.
Because heat pumps are VRF as well.
Yeah.
And so is heat recovery, right? So
Sure.
heat recovery VRF machines do heating and cooling simultaneously. And then the heat pumps, you have heating or cooling, but not simultaneously.
Right, one or the other. And so the
Yes.
heat recovery, I think heat recovery is the thing that people kind of question and get concerned with the most, right? When we start talking about heat pumps, that's really what we're talking about is
Yes.
heat pumps. But when we add the whole capability of doing heating and cooling at the same time, we go, all right. So this is different than what I'm used to. And maybe because it's different, I'm just not going to learn about it. And that's really not the right approach. What we should be thinking about is, how does it compare to the things that we already may know? And then now we come to class and we learn what's different about it, right?
But it's actually exactly what we know already. It's the same refrigeration system.
Right.
You still have subcool. You still have superheat.
Still got a
compressor. Still have a compressor.
Condenser
Still have a
metering
fan motor.
device.
You still have indoor units, but you have multiple indoor units, and the refrigerant is controlled and depending on the need.
Yeah.
So we're not wasting energy on a traditional unit. You turn it on and it's go.
Right.
VRF, you could consider it to set it and forget it, right?
Yeah.
So it just cruise along throughout the day, maintaining temperature.
Yeah.
It's less. It'll cost you less to just maintain temperature than to coming home after work, turning the system on low.
Yeah.
and trying to get your house cooled, right? So if you just set it and forget it,
Yeah.
you'll cruise along
great
and
term.
save money, right?
Yeah, that was one of the things that I
Yeah.
really took from this class is kind of retraining our old mentality of, okay, if I'm going to conserve energy, why don't I just give it a big setback, or why don't I just shut this off? And that's really not the case when we're talking about VRF, because some of these pieces of equipment have the ability to run down to like 15, 20, 25% capacity, very, very low capacity. So we can get longer run cycles with extremely low operating current in amps. Right. And that's really the biggest thing. So if we talk about like what is VRF, and we look at some of the differences, we may add things like, say, like a branch.
Like RBU.
Yeah.
So heat recovery, having the ability to do heating and cooling simultaneously, requires an RBU, which is a refrigerant branch unit that goes between the outdoor unit and the indoor units.
Okay.
Right. So
just an additional component.
Yeah, just an additional component to capture that thermal energy that would be displaced.
Right.
We'll grab that thermal energy with the RBU, send it to a unit that's in need. So, and we're not wasting energy per se.
Yeah,
right?
Exactly. And it's a very interesting philosophy when we think about that. If we're trying to explain to students, or we're trying to explain to other technicians how a heat recovery works, you can get really complicated if you want to. But if you step back and go, actually, we're just removing heat from one indoor space. And then we're going to use that heat. And if we need to actually put it in another place, instead of just rejecting it all outside, we're going to move it into another area that could actually use that. And so we spent a lot of time looking at that today, and looking at the differences that we have in equipment. So let's look at ways that these newer modern VRF systems are actually really easy to work with.
Oh, they are. So that's the thing. So even when I first started, I took the panel off. I saw the computer, right? Because that's what everybody. And you're so afraid, right? But if people knew, right? This is why I do these classes, to make people comfortable. Because all you have to do is be comfortable, to work on the equipment. So when you take off this door and you look at this computer, there's a 7-segment display there that if you have the service manual, you have instructions on how to use those buttons, and you'll come to find out you don't even need to hook up your gauges.
Isn't that crazy?
You could check every thermistor without bringing out your meter, just by pushing these 3 buttons and having the service menu with you. So it's actually, if there's something wrong, the equipment tells you what's wrong. You don't have to get yourself crazy. So just getting an understanding of the equipment, you'll come to find out that it's actually something that you already know. And it's easier to deal
diagnose
with than a rooftop unit or a residential unit. And VRF is not only commercial. Again, we have a J series unit, which
we can use
you
in
can
residential.
use residential, as we have a 3-ton, a 4-ton, 5-ton. So we do have VRF units that can be used as residential as well.
And I think we'll see a lot of that going forward. I think we'll see more of these residential applications because of the technology, the energy efficiency that we have. But it's sometimes a struggle for us as educators and as contractors to move into new technology. And what I really gathered from this, and by the way, you and John did an amazing time like teaching us this technology, because I've spent a lot of time in building automations, and I've worked with the technology, but to be able to look at the piece of equipment and really have a broken down perspective of it, it actually cleaned up some of my misperceptions. Like if we think about it just as a technician, because even as educators, I mean, really, we're technicians. So if we think about, like, if it was a residential system, think about the technical support calls that I used to get working on residential unitary split systems. What are the most common technical support calls that you get with VRF technology?
So you get calls when installers are not following the directions. So if I always say, if everything is clean, dry, and tight, you should have no issues. But the number one call, to believe it or not, it's a low charge, because another thing is torque wrenches are not being used. So paying attention to detail will have a nice install that you shouldn't have any issues. I've seen these units installed, and if they're installed correctly, you won't hear from people. Of course, you want to hear from them to do maintenance,
right.
and stuff like that.
I love this. You guys did such an amazing job. We haven't had to do repairs. in years.
Exactly. They might, of course, you got to remind people to change their filters and stuff like that. Just
routine
or maintenance programs that you can sell. But
absolutely. All right. So let's take a look at some of our options, so people get an idea of the different types of VRF designs that we can utilize for commercial as well as some of these residential applications.
Okay. So this is just comparing VRF systems, right, which have a high heat transfer capability, right?
Mm-hmm.
Like chiller systems have a lower heat transfer capability, and then variable air volume systems have the lowest.
Okay.
Right.
Yeah.
So that's just comparing to them, right? And also
Right.
with a traditional unit to move air of 20 tons, you would need 30-inch duct, right?
Right.
So with chilled water, you would need 2.5-inch pipes. And then with the VRF, the largest pipe is going to be 1 1/8.
Okay.
Okay, 1 inch and 1/8.
All right.
Okay.
So pretty significant difference in the size
Yes.
that we're going to be talking in the difference of them.
Correct.
All right. So let's skim forward a little bit.
Yep.
And so these are all pieces of, 3 days worth of education. So we're taking
Yes.
probably 600 slides and breaking them down in about
Yes.
15. So it's quite the overview, right? And so when we're talking about transitioning in fuels in particular, right?
Yes.
We're all talking about decarbonization, we're talking about electrification,
Correct.
and we're talking about ways that we can look at technology for making some of these, particularly the fossil fuel transitions.
Yes.
Let's look at some of the benefits and the opportunities with utilizing the technology.
So one thing, however, is like traditional installers and contractors.
Yeah.
One thing that used to happen that doesn't need to happen anymore is setback.
Right.
Setbacks. So
right.
a
It
traditional
used to be big.
Oh, they used to be
energy
10 degrees.
co-ops, and they were always
Right.
saying, let's use a lot of setback to save energy.
Yeah, and they used to save money because the systems were grossly oversized, right?
Always, yeah.
They
and single stage, maybe two stage, but typically
yes,
single stage.
they were very low efficient on all operation. They used lots of fuel, right?
Right. Yeah.
So now fossil fuels are not dependent on outdoor temperature to produce heat like the VRF systems
Sure.
are, right?
Right.
So now with these, you're going to save money because, like I mentioned earlier, you set it and forget it, and it's
Right.
going to cruise along. And maintain temperature is going to save you more money than coming home after work and ramping the AC up,
cranking everything up.
And it's going to take a while. It's going to use a lot of energy.
Yeah.
You're not using gas, now you're using electricity.
Yeah.
So you're trading off, but it uses very minimal energy.
Mm-hmm.
We went over the class. You saw the amp draw of our indoor units, which is
on these
less than a light bulb.
Yeah,
right.
Exactly. Some of those run on half a watt or half an amp for indoor units.
A quarter
total indoor unit, right?
Yes.
Yeah. So a pretty significant difference than what we would take a look at as like a PSC blower motor that's drawing, 6-7 amps, 8 sometimes.
Exactly.
Right.
It's a big difference.
Sure.
So I understand that there's commercial buildings that might need a setback once in a while, but with VRF systems, you might want to do a 3-degree setback.
Yeah.
And if it's going to be extremely cold at night, just postpone the setback altogether.
Yeah, just let it run.
Because with our VRF systems, we'll be able to, go and change parameters. And, if you know that there's going to be a cold night, you might want to stop in or log in and change the parameters for that night and
let it run and gather heat. And these things are running down to like minus 15?
Yes, minus 15.
Okay.
Yes, sir.
So pretty significant amount of heat as we start looking at the capability of these, right?
Yes, sir.
So we talked a little bit about those setbacks.
We talked about the setbacks, extreme cold conditions. Again, just postpone the setback altogether.
Sure.
So then why is it not recommended to do setbacks, however, with heat pumps? Because they continue heating the space with very minimal energy use. So that's why. And again, ramping up is going to cause you to waste a lot of energy. So setting it and forgetting it would be the way.
Sure. Now, in our classes, we had a lot of over half of our class were contractors.
Correct.
Right. But we also have residential technicians that are looking at the equipment, going, "Hey, we're getting a lot of VRF coming into residential, and so we got to get more comfortable." That's why we talk about getting educated on what this equipment is and how it functions and the benefits of it. And when we talk about some of the equipment designs and layouts that we have, let's look at some fundamentals.
Yes.
For those that, like many of us that were in here, don't understand the fundamentals behind the technology, let's dive into the fundamentals of what we're doing here with these new generations.
They're going to see that it's something that they already know. Like I touched on it earlier.
Yeah.
What happens to the thermal energy, right? So refrigerant transfers thermal energy from one place to another. It hasn't changed. We didn't invent anything new. It's the same process, right? That's it.
Yep.
So if we're in this is the same refrigeration cycle that everybody knows. We have the condenser, we have the expansion valve, the evaporator, the compressor, right? Same flow. You still have your same steps. Everything is exactly the same, right?
Sure.
So then with the VRF heating cycle, the function is to transfer that thermal energy from the outdoor unit to the indoor unit for heating. for cooling. It takes that thermal energy and transfers it from the indoor unit to the outdoor unit for cooling. And then the VRF, the magic happens where that thermal energy that otherwise would have been rejected outside,
yeah.
it gets used again and sent to another unit that's cooling.
Repurposed.
Repurposed, of course.
Yeah.
You know how we do that though? How do we repurpose?
Yeah, I don't know.
You don't remember from the class?
Oh, I do. I do.
You
No, I'm just kidding. And if anyone out there, we're actually trying to bribe you to join in with us and fill this in a little.
So with the help of our RBU, the refrigerant branch units,
Yeah.
we're able to capture that thermal energy and then send it to where we need it.
Right.
Instead of just throwing it outside.
So when we talk about when we're talking about using a heat recovery, now we're talking about just a 3-pipe system, right? So the outdoor unit, instead of having just the 2 pipes, we're now going to use a 3rd pipe that are going to go to our branch system where we can now direct the flow to the indoor units that are calling. So like if I've got, say I got a multifamily, right? And I got one family that's needing some heat, and then I have another family that's needing some cooling. Well, instead of having to have 2 different systems moving energy, we now have one system that's just transferring the energy.
Exactly. There you go. You got it.
Yeah.
That's it. So if the person in apartment 1, it's cold, they want to turn on the heat, they can. And then the person in apartment 2 wants to turn on the heat, they can. Or they're hot, they want to turn on the AC, they can.
No problem. They just transfer it around.
Correct.
All right. So really, when we look at the design, it's really not that different of a system, except for the fact that we're just, instead of rejecting all of the heat outdoors, we're now going to start utilizing that heat, or in the same way in the cooling, instead of rejecting, we're just going to be moving and transferring things around. So we spent a lot of time diving into the VRF side of things. We're going to move around, have some different questions, and then we're going to come back and we're going to talk about resources, because the goal is to make sure that every educator and every contractor that is starting to focus on new technologies have the resources like this amazing technical training facility. And so we'll come back and we'll regroup on that here in a little bit. And I really appreciate it.
It's my pleasure.
And I'll see you here in just a few. So we're going to go ahead and take a walk around the technical training facility here. And we're going to make a transition over to Ty and John. What's going on, guys? How are you?
Hey, we're doing great. So, so what are some of the biggest reasons that you see educators not wanting to adopt this technology into the classroom?
Just finding that it's hard to get information. As Clifton mentioned earlier, as technology advances, we need to educate ourselves and to stay up to speed on that. So you can't teach what you don't know. So as educators, we have to stay up to date with the emerging technology as it comes out.
So I got to admit, when I first came into this class, I was a bit overwhelmed. There's all of these control boards, all this technology. There's DC voltage coming through here. There's fuses everywhere. There's dip switches and all kind. I was overwhelmed, right? So I was coming in. I was like, oh man, this is outside of my comfort zone. This is outside of my expertise. I mean, first I come in here as an educator thinking we got to train people for this technology. This technology is here whether we like it or not. But after taking this class, coming through and learning from you, and it's not just sitting here going through the slides. They're actually teaching us how to avoid installation problems that make the system last and how to make this equipment with all this scary technology very dependable. And then once they go through this class and they're showing us how these things work and how to use the resources to solve the problems, I feel very comfortable working with this. And it wasn't just the fact of us being here. We actually got our hands on it. We used meters. We actually set the switches up to set this equipment up. And now I feel very comfortable with it. So can any educator come in and take this, or how can educators get the training to learn about this?
Absolutely. Anyone is welcome to come in and take the classes that we have, as long as you understand the basic vapor compression cycle, the basic principles of refrigeration, then you're going to be able to pick up on this class and go right through it. They can stay in touch with their local distribution, find their local Fujitsu reps, see what classes they perhaps have. If they have a Fujitsu training academy at their local distributor, which is an option to open to distributors to set up a classroom like this, or they can find out their own on their own, come to class. We have a training facility here in Texas. We've got one in New Jersey and one in California, and they're welcome to reach out, contact us, and attend our classes.
Now, if an instructor cannot get to an actual class in person, do you have any kind of online resources where they can learn?
Absolutely. We've got the Fujitsu Connect website where they can go to their online learning portal and can take classes online. The preference of The benefit of being here in class, like you said, though, is it's getting your hands on the equipment. It's one thing to see it on a screen, but if you can actually work on a piece of equipment live, follow the sequence of operations, and it's muscle memory. Where do I put my meter probes? What am I looking for? How do I test this equipment? And then just following the flow through the diagrams and through the circuits. They're very simple and easy to learn and to work on.
Now, what resources do you have available for instructors that they can learn about troubleshooting? They have problems and need to work what out. What resource do you have available?
Absolutely. We've got our Fujitsu tech support, so they can call into Fujitsu and get on the tech support line. We have the online Zendesk portal, which has all of the manuals and instructions that they can access and have the books and the manuals. And we even have a mobile technician app that they can download to their phone, and you can actually go through the app. If you're dealing with an error, you can punch in your error code, and it follows you through a flow chart step by step on what to do, how to test the equipment with pictures of where do you put your meter leads and how do you test.
So when we first started out, these instructors are just amazing. They knew these codes. They were popping off numbers. And I was thinking there is absolutely no way with my dyslexia, with my struggle with numbers, that I'd be able to get this stuff down. But then they showed us where we have books and it has flow charts. Hey, this equipment's giving you a code. Find this in the book and it tells you A, B, C, exactly what to check. But me personally, I struggle with books and what page it was. I was actually looking over at Eugene and letting him find it in the book. And then they found out the app, and I love apps, and Eugene preferred the book. I love the apps, and the apps had you enter that information and it had those same step-by-step things to find it. So whichever method you prefer learning, I thought it was amazing that there was so many step-by-steps, whether it's the book side or somebody loves technology and apps like me that was able to work through this. I was very impressed.
Absolutely. We realize that everybody has a different learning style. Everybody learns a little bit different. So having the ability to show slides in PowerPoint, having videos available, having the hands-on, having different technicians, having different instructors, we all have different backgrounds. So we all approach teaching from a slightly different aspect. It just provides a complete immersive learning atmosphere where students can really come in and feel comfortable asking questions and really working on the unit so that they're comfortable when they go back to their training facility, when they go back to their company, their job, and actually have to do this. They've already done it here in the class and they're comfortable.
And hands-on training for me is a great, very powerful way to learn. But make sure you get the training. You don't want to be putting your hands on this without the training, because there's things in here that will be a shocking experience for you. So we want to make sure that we know exactly where to put the hands on, how to use that meter, and make sure that we're comfortable with our ohms, right? We want to make sure that we know exactly what we're reading, and that's what the power of these classes. And it's great to be all of this. It's like super scary stuff is like very simple. They tell you how to get the panels off and how to get to the equipment, how to test it. And once you realize that you're just testing individual components and you have technology that guides you what to test, absolutely amazing. I was very impressed with this class. And man, I would take this class again just because the instructors alone, plus all the technology.
Thank you, Ty.
All right, let's head over to Eugene. And Eugene's got some really great questions. If you guys know Eugene, he's one of my mentors and he always has a massive amount of information.
Thanks, Ty. So yeah, just to recap, for the last 3 days,
Yes.
we've been immersed in what's going on here, and it was really, 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 really. I'm waiting for the camera to catch up to me. It was really, really, really intense, and Juan and John did an absolutely amazing job over the last few days.
Thank you.
So thank you for that. Thank you for allowing us in. And over the last few days, the vast majority of people who were in attendance in this class were contractors and technicians. And it's already been mentioned that it's really, really important for educators and teachers to take advantage of this training, because I've said for years, if a teacher doesn't know something, they won't teach it. If they don't teach it, their students can't learn it. And if the students can't learn it or don't learn it, they can't do it. So I think the really, really important thing is diving in. Because walking in on Tuesday, and it was a little overwhelming looking at the guts of a VRF system, and you and John did an amazing job of just peeling back the layers of the onion to give us a really, really good insight into what's going on with the system, and you really have a knack for guiding us through step by step by step by step. And we're standing under one of those refrigerant branch units that was alluded to earlier.
Yep.
And you kept mentioning time and time again on these systems the importance of the pink wire. And
The
you were
pink
talking
wire.
about so much stuff over the last 3 days, and I kept thinking back to the pink wire, because I look back at the days when I was actively in the field in the 80s and 90s,
Yes.
and when we ran control wire,
Mhm.
it was 24 volt, and we
Yes.
were running our hot chocolate, we were running our low voltage wire connecting. Never really thought too much about the wire.
Yep.
And you and John were stressing the importance of the pink wire. So for
Yes.
everybody out there, please, Juan,
The-
talk about the pink wire.
The good old pink wire, right? So the pink wire is our communication wire. So this wire is what goes from the outdoor unit in a heat recovery system. It comes here to the RBU, and then the indoor units use the pink wire to be wired into each port of the RBU. So this is our communication wire. It's a Honeywell wire, part number 3254.
See,
Right?
I did my homework. I did my
remember?
homework. Yeah.
But the thing is, the wire is pink. That's the wire the color we chose. Pink makes it very easy to open a ceiling tile, and for me to look in there if I'm doing a job site and see, oh, I see that pink wire. I know that they use the right communication wire. So if I went to your job site when I was at one point I was the regional support specialist, and you had communication issues, and you didn't have that pink wire, guess who was running a new pink wire?
All right. So to word to the wise, if
Yes.
you're installing a system and it's not pink, you
Yes.
either need to get pink spray paint so it looks
Hey,
pink.
if you don't have any communication issues, I won't bother you. But if you have a communication issue and I come and I don't see that pink wire, you're gonna have to replace it at that point.
Yeah, if you get nothing else out of this Fujitsu training,
Yes.
it's Honeywell 3254
Yeah, so
wire.
it's sold by our distributor. It's 500-foot rolls and 250-foot rolls that they sell it. And if you need more than 500 feet, you might call Honeywell and get a different color, but it has to be that 3254 part number.
Shameless plug, but
Yes.
yeah, and it's I'm talking about the
Yes.
pink wire, but
Yes.
the manuals that we went through over the last 3 days,
Yes.
it's actually insane the amount of material that we covered.
Mhm.
But again, people think communication is communication, and it doesn't matter. We're sending a signal over a wire.
Yes.
So a lot of times we don't really think, like the average technician. I didn't think about it,
Mhm.
but you guys opened my eyes to that this week. That it's not it's the road, it's the surface of the highway. What kind of highway? We're connecting point A to point B, but it does matter. And yeah, a lot of discussion was had this week about variable refrigerant flow systems. And I'm thinking back to the systems that I worked on in the 80s and 90s. All right. Those air conditioning systems had 2 speeds.
That's it.
On and off. So when I'm in front of my classroom and I'm
Yes.
speaking to my students,
Mhm.
and I'm talking about a conventional single speed air conditioning system, I speak to my students about, okay, picture a car at a red light,
Yes.
and that red light turns green, and the driver floors the car and speeds up to the next corner where the light's red,
Yes.
and they jam on their brakes to stop at the red light. Then they're sitting there waiting, and then that red light turns green, and they floor their car again, and they speed up to the next intersection.
Sounds
They hit the
familiar.
red light. Yeah, well, you're from the Bronx. I'm from the Bronx, so we kind of get it.
Yes.
So, and the car is constantly starting and stopping,
Yes.
and we know that the car is experiencing a lot of wear and tear,
Correct.
like constant starting and stopping, and the brake system on the vehicle, right?
Yes.
And now I paint that picture in my student's brain, and then I talk about a variable refrigerant flow system where, okay, the same car is
Yeah.
at the red light,
Mhm.
the light turns green, the driver eases off the brake, gently presses the accelerator, and the car gently moves forward.
Yes.
And then
There
when
is
the
no red
vehicle
light.
reaches the next intersection, the red light turns green and the vehicle continues to go.
Correct.
And we're talking about energy consumption.
Yes.
And I know you were discussing with Clifton earlier, but again, back in the 80s and 90s, we always told customers, oh, when you're leaving for work, turn the system off.
Yes.
And then when you come home from work, turn it on. And then programmable thermostats hit. And I was like, okay, well, you'll turn the air conditioning system on like an hour before you come home.
Okay.
But you know, you use the term with Clifton, set it and forget it.
Set it and forget it. It's the
And
way to go.
yeah, and it's actually really, really interesting because the knack that you and John had this week, just driving that point home. If the
Yes.
system is properly sized, installed, maintained,
Correct.
you really don't have to think too much about it.
Just clean the filters.
Yeah, well, there you go. So one thing. So
Yes.
a lot of thermostats, and again, you touched on it earlier, so I just want you to elaborate a little bit more if you could. The whole concept of setback thermostats.
Yes.
So again, in decades
Back in
ago,
the day,
it was everything was setback, everything was setback, everything was
I
setback.
think they even make thermostats that come programmed already with a setback, if
Yeah.
I'm not mistaken.
So
Yes.
just reiterate again
Okay.
your take on
So-
setbacks and why they might not be the best option and when they
So-
are appropriate.
Before, the systems were grossly oversized, right? So cool the space down really fast. It didn't care about the outdoor temperature, but the VRF systems do consider outdoor temperature to perform correctly. They manage the refrigerant flow. They're not sending refrigerant where it's not needed, right? So you're saving more energy always, right? So doing setbacks on a VRF, it's not recommended because it's going to use way more energy to bring up the temperature in the space again when you could just set it and forget it, right? So maintaining temperature, that compressor will cruise along at 20 revolutions per second. And if you have a multi-outdoor system where you have up to 36 tons, we could have. I've seen systems running at minus 13
Crazy.
with all three compressors at 20 revolutions per second, maintaining 68 degrees at minus 13 outside. That's impressive. So these units can do a lot and save energies if just set it and forget it.
Well,
Remember that.
Yeah. Let's think back
Yes.
about those systems, those single speed systems.
Mhm.
So my father's been in this industry for many, many years, and
Mhm.
his theory was, I want that system. So a lot of times, a lot of companies, a lot of contractors would design systems for the hottest day of the year.
Mm.
Well, how many days of the year is the hottest day of the year? By definition, the hottest day of the year is the one day
That one day
at which the temperature is the hottest, right?
Yes.
So my father had the mentality, I want to sell somebody an air conditioning system that's so big that they could open up the doors and take the roof off the house and air condition the entire neighborhood.
Still.
Yeah. So
Yes.
so that was my father's mentality back
Okay.
in the day.
Mhm.
But think about it. You mentioned, and we were discussing the constant starting and stopping,
Yes.
but think about the humidity issues in the house.
Ooh.
So you would have an oversized air conditioning system turn on,
Ooh.
and then it would satisfy the sensible load on the space very quickly,
Correct.
turn off. Meanwhile, the house is now becoming cold and wet.
Wet.
So how does a variable refrigerant flow system address the humidity issues? Yeah, obviously we're ramping compressors up and down, to
Right.
speed.
So you have to size it to size. So no more oversizing. Do your manual J calculations and all your calculations that need to be done and match it to size. Right. So again, people still do that. They'll put a big unit like a 36,000 BTU unit in a 900 square foot space. I've been to
You can
those
hang
job
meat in
sites.
there. You can hang meat in the living room, right?
And I mean, it's gonna. I seen wallpaper peeling off the wall. Because they thought it was going to fix itself by putting it down more, but no, if it's oversized, it's not going to work correctly. These systems are not to be oversized because they work perfect the way they should be, the way they're installed, if they're sized correctly for cooling.
So now that you brought that up, if
Yeah.
I have a 5-ton outdoor unit,
Mhm.
do I have to install 5 tons of indoor units?
No. So it depends on which outdoor unit you have. For example, on our V series, you could do 1-to-1, which is 50% of indoor unit connected capacity. The VU5, the V series, I'm sorry, excuse me, is 100% 1-to-1. But the J series, for example, which can be applied to a residential, you could do 50% of indoor unit connected capacity
Up to
150.
So there's some flexibility
So
in
you
there.
have some flexibility, and then you're not going to put 150% of indoor unit capacity and then you're magically got that much. You still have the same as your outdoor unit, but throughout the day, the load is going to move around depending on where the sun is, who's in the room. You're not going to be in every room every time. There's going to be units that are off. So it's a system. It's like having control of each space in your house without dampers or zone boards or anything like that, just a controller in each room, you'll be able to manage the space, right? So
Yeah,
you save energy.
and the way I explain that to my students and people that I work for, look at your circuit breaker panel in your house.
Yes.
So you might have a 200 amp service in your house. Your breaker is 200 amps. That doesn't mean that you only have 200 amps worth of breakers in the panel. Not every appliance, not every light is on in your house at the same time. So you might look at your breaker panel and you might have 300 amps or 400 amps worth of breakers in your panel,
Yes.
but you're not using them all at once. So the whole concept of managing or sizing your indoor units, again, like you said, not every indoor unit is taking care of a space that requires maximum capacity.
Exactly.
So yeah, there were a lot of takeaways this week. This was a really, really exciting week. We had an amazing time with you. Like I said, we had a lot of contractors here. We had technicians here. Challenge to you educators out there: take advantage of the training that's being offered to you. I've been saying this for years. Again, if a teacher doesn't know it, they can't teach it. They don't teach it. Students don't learn it. Students don't learn it. They can't do it. So I learned a lot this week. I know a lot about VRF.
Yes.
I have to research, for books and projects.
Yes.
But these last few days really, really, peeled back the onion, peeled back the curtain, and gave my colleagues and I a lot of deep insight into exactly what you guys are doing. Beautiful facility.
Thank you so much.
In a few short weeks, we'll be visiting Air Stage on Broadway. We'll be in Manhattan, so we're excited to visit that location. So yeah, definitely take advantage of the training that is offered to you, whether you're a contractor, a technician, an educator. The training is out there. So
and it's not like anything new. They already know this equipment. It's just getting comfortable with it. So you come here to just get comfortable. Take the panel, put your hand in there, and it won't bite. It's just not gonna bite.
Yeah, it can be intimidating when you first open up a piece of VRF equipment. It looks like a copper factory exploded in a confined space. But every piece, every component has a purpose.
Correct.
And the training manuals, the support materials that are available, you're not out there by yourself, and that's really nice because over the last couple of days, you guys presented us with problems and challenges, and you let us get familiar with the training manuals, so we learned how to look things up and find things. And I'm really, really glad that we were able to to join you.
I'm so happy you guys came.
Hey, Clifton. What's up? What's up?
on over here. What's happening?
Yes, sir.
Well, there's a couple things I'm gonna grab one for a minute, Eugene.
Right.
I appreciate that. We're gonna make our way over because you just mentioned all of the components. We're gonna head over and talk to John here in a minute about the actual components within a VRF system. But you'd mentioned the residential applications, and a lot of times people don't think about the residential applications. So in this station, we actually have a variety of residential product lines that I'd love for us to cover just a little bit before we go over and open up a VRF and look at all the individual parts.
Okay.
All right. So what we got here?
So this is a residential. This particular one here, this is actually the same chassis and body as a VRF.
Okay.
Single fan J series,
Yeah,
which is a J4S. It looks exactly like this, but this is a residential. This particular one here is a 36,000 BTU
3-ton. Yeah.
ducted. This is a ducted unit is with an A mug, which is it looks like a residential.
Yeah, it looked like a
unit.
traditional residential air handler when we've seen this.
So this is one of our newer units, which you can drop in. Just like if you have an existing ducted
system,
unit,
right?
You can actually make sure it's sized correctly. Though the same principles apply with the airflow. This is
it's all about airflow.
Refrigeration. This is the same thing. It's all about airflow. So make sure you have the correct static pressure set and all that.
Okay.
So this is one of our residential units. We have ducted units.
Yeah, I definitely wanted to point that out. Some of the options. A lot of people think about a residential and they go, "Oh, I got wall units." Yeah, that's all that I got to buy, right?
No, we have ducted units as well that can be concealed.
Sure.
In the ceiling, right? You can do maybe 3 supplies with this one. You do a primary bedroom. Excuse me. Yep. You could do with that one, or we have varies. We have again the wall mounts. We have cool controllers. Right, as you see there. So
Nice.
the equipment, it's again
A lot of flexibility.
a lot of flexibility.
Sure,
and
absolutely.
available for you. Right?
So let's head on over and we're going to spend some time learning about some of the components within a VRF system. So I'm going to hand this on over to Ty and John.
Hey, John, we got this. I think of all the systems, this was probably my favorite of the class because it works with commercial and residential systems. So I thought it was pretty cool.
Absolutely. So Ty, the process of learning is taking something that you're already familiar with and adding something new to it. So let's take a look at some of the components, and let's start with the familiar. Right? So in any refrigerant system, any mini split, any heat pump system, you're going to have your compressor down here, and that's exactly what it's going to do. It's part of the vapor compression cycle. We're going to have a low pressure vapor. It's going to compress it and get a high temperature, high pressure vapor. So there's our compressor.
And in the class, we stressed so much about the installation to make sure that we had the proper amount of vapor coming back in, and it measures to make sure it doesn't overheat. So just like with a standard air conditioner, you have to have oil return, you have to have the proper amount of superheat coming back to it, so we don't burn that thing out. So it's very similar to traditional system.
Absolutely. Then, depending upon the mode of operation, whether we're in heating or cooling, we have our reversing valve here. So it's either going to send that hot gas to the outdoor unit for air conditioning, or it will send that hot gas to the indoor unit, just like a standard heat pump. We have our outdoor coil here, and we have an indoor coil, depending on the mode of operation. It's either the evaporator or the condenser, depending on what you want, whether you want heating or air conditioning. So now let's take something new that they might not be as familiar with. We've got our printed circuit board here, where we're monitoring all of the temperatures and pressures through the entire system. And then the system is responding, managing that refrigerant flow based on changing conditions inside and outside. One of the other additional components that we have is we've relocated the expansion valve from the outdoor unit, like you'd see on a traditional mini split. The EV is located at the indoor unit now. And that helps get us longer pipe lengths for some of these larger commercial projects. In addition, we've got a subcool heat exchanger inside now that actually subcools that refrigerant in most of our systems, not all, to gain those longer pipe lengths. So a lot of it is stuff that guys are already familiar with working on. They've already seen. It's stuff that they already know. Now they've just got to come up to speed with the additional thermistors, the additional EEVs, and how that's all managed through the printed circuit board, and just getting familiar with the test points on the board to see where things are going and how things are working.
I think a lot about the automotive side. If you have an old carburetor car, you still had internal combustion. You still have air, fuel, and heat and to make that engine move and work right. But then we come into fuel injection where we add electronics, we add a computer, and we add sensors. We're able to fine tune that so that works with multiple conditions. I remember my old carbureted truck. I drove it at the Pikes Peak, and it just about not made it there. I had to have 1 foot in the brake and 1 foot in the gas going up the hill because there's no adjustment. I had to tune it again when I got to the top, and then I was running so rich at the bottom, it was such a mess. And with fuel injection, I didn't have that problem. So I look at this as being the fuel injection of HVAC. We have control boards that adjust for all the conditions, and we have sensors that are monitoring it. And as long as we know how to check the sensors, work with that control board, it's really not that scary, and it makes it work more efficient and also long term. We talked about the warranty in this, and if it was installed correctly, you said what was the warranty you talked about?
So for a contractor that has been through the Fujitsu training, is a Fujitsu elite dealer, their warranty is 10 years on the compressor and on the parts. Because we trust our contractors, we know that if they've been to the class, they're putting them in right, these systems are going to last and they're going to be trouble-free and not have any issues. And if they do run into a problem, something does happen, things happen, they can call the tech support department. Tech department will work with them to go through the system, not just change parts, but actually diagnose. Get in and see, okay, what failed, what caused that failure. We'll get you the parts under warranty, and then we'll help you get them changed out and prevent future failures. It comes down to refrigerant flow and airflow, and as long as you've got those two things and good power, clean voltage, these systems will last.
I loved going through the class and all of the examples of, hey, this wasn't done by the book or this wasn't done properly, and that caused the issue. So taking the class and learning about it is absolutely essential. And I really found the class had 3 different breakdowns. One was just understanding the system and how it was installed, which we have to know how it's installed. And then the second was the service side of it. So after you understood how it was installed, then you could work in the diagnostics. But if you didn't understand how it was installed, you really couldn't get the diagnostic side. And then the third part was maintenance. And this isn't just a typical system. You just go and spray water in it like you used to. There's very specific steps. We won't cover that. You have to take the class to cover that. There's very specific steps for the maintenance. So it's not just like you send somebody out and they just look at it and say it's okay. There was very specific steps. So taking the class and learning about it is so important. Oh, and what types of protection do we have?
Absolutely. There's 3 types of protections built into every system. We've got our electric protections, our temperature, and our pressure protections. So inside that board, we're monitoring voltage, pressure, and temperature throughout the entire system. And those protections want the system to run. So they're going to continue to try to operate, but at the same time, they're going to prevent the system from hurting itself. So if we've got a voltage fluctuation, or if we've got power that's coming in, we've got our electrical protections. If we've got a transient condition where maybe a tarp or a bag blows across the back of the coil there, we've got our temperature and pressure protections that are in place to help the system to run. And eventually, if it just can't run any longer, it will throw an error code on the 7-segment LED. The technician can come out, look it up, look up the error code on their app, and then follow the flow chart and the diagnostics through to figure out what caused the problem and how to fix it.
So you said with these systems do heating and cooling. On the heating side, how low can they operate to?
So these systems are designed to operate down to -15 or -15 in the winter.
That's pretty impressive right there. I remember the heat pumps of my day. We had an old time clock in it, and you got down too far below 30, and it was struggling. So it's quite amazing, the technology, but not just the technology. Like you mentioned, those protections. So it's sensing, it's trying to fix itself, it's trying to adjust. And when it gets to a situation where it can't solve it, such as there's something blocking the condenser, it goes into that protection mode so it protects itself. And there was several examples in class that they gave about, hey, here's the code that comes up, and then how to transfer what that code means to the diagnostic steps. So instead of it being just electronics everywhere, use technology to communicate with us. And I thought that was pretty awesome.
So part of the problem that the older systems had was that the compressor would run and it would load up on heat and it would generate heat, and then it would shut off. And then it would load up on heat and shut off. So you'd end up with this cycling on and off, on and off. And while the compressor was off, the house would get cold. It would cool down. So people didn't believe that heat pumps worked in colder climates. With the newer inverter-driven compressors and our ability to monitor and measure the refrigerant flow, control that flow of refrigerant through an electronic expansion valve, now our compressors operate very smoothly. It's almost like hitting cruise control in the car, where they maintain heat and they stay at that steady state of operation. And because of that -15, if you do your load calc, we can design the system to meet your demands at that design temperature. And then the compressor just ramps down on those more mild days. So we can heat houses down to very cold temperatures safely.
And when I'm looking through here, I see like there's piping. It looks scary, but once you break it down, you have a compressor, your reversing valve. You have some electronic expansion valves that you're going to be using for the heating side, and you have some familiar stuff like the suction line accumulator that protects the compressor. And really, you're looking at the piping, and once you follow it, it's not nearly as scary as it was when I first came in. And then when I look at the control boards and think, wow, there's really scary components to actually break down what each of these things do in the control board, which I've never had any of the other classes I go to actually tell you what those pieces of the control board do.
Yeah, Fujitsu does a very good job on the inside of actually putting labels and tags. So when you look at something, it'll tell you this is thermistor number 6, this is thermistor number 1, and what it does. And then it comes back to the connectors on the board. And Fujitsu's manuals actually tell you what connectors they are, what they go to. And then we've got our service tool software that we can hook up to this, and we can see all of those temperatures and pressures, and we can watch the flow of refrigerant through the system and actually understand what's going on inside the system, so we can determine whether or not the system's operating properly, or if we need to make some adjustments to either to the installation or to the operation of the system.
And that service tool I thought was really cool also. They were able to plug into the system and they could pull up data for what, the last 30 days?
So we have our ASIC controller, which ties back to the web, and it'll store data for 30 days. If a customer opts not to go to the web, our service tool software resides on our laptops. We can plug our laptop in, and as long as we're connected to the system, we're recording all of that data, and we can get all of that information. Our service department, we can either email that data to them and they can dig deep into it, or we can request them to contact us. They can send a remote message signal out to it, a go to learning or go to training type signal, where they can then see our laptop from the tech department and follow along and take over the laptop and actually see what's going on in the system.
I thought that was really cool, being able to see the tracking. We looked at a system that has low in refrigerant, and we could see the tracking from the graphs through the tool. And also we had error codes that pop up to let us know we had a low refrigeration system. Now, if we're low in refrigerant, one thing that was stressed in the class was leak checking. So before we'd leak check for a little while, but here, because we want to make sure there's no leaks and we have more connections, they're pressure testing up to 600 PSI for how long?
So it's a best practices system. So we want to see a 600 PSI pressure test for a full 24 hours to make sure that the system does not have any leaks. We want to make sure that we're using dry nitrogen so that we know we're not adding any moisture into that system and we're getting a solid pressure test. After that, we want to pull our vacuum, pull it down to 350 microns, and then watch it for an hour. Isolate your vacuum pump, make sure your digital micron gauge is on the system. We want to make sure that we stay below 500 microns for an hour so that we know we have a completely dehydrated system that is sealed, tight, and dry. As Juan mentioned earlier, if it's clean, tight, and dry, and you charge it properly, this system's going to run.
It's amazing difference. We talk about that decay test. I talk about vacuum all the time, and I talk about giving it time and see if that moisture re-evaporates out of that system. But here they're giving it that decay test, that waiting for an hour to make sure it doesn't rise above 500. You're all the time 500 microns, like that's a goal. No, we want to be below that. We want to make sure we don't ever rise above 500. 500 is the limit, not the goal. That's like their highest level. Because if we get that moisture out, we're good. And we always hear people talk about, well, what if moisture freezes in the system? If you wait for an hour on that system, if there's any moisture in there, the heat exchange of all of this tubing is going to have that ice melting very quickly back into a vapor. You're going to see it very quickly on that micron gauge. So I love the fact that it's so specific and using that long enough to hit the delay time.
So that's part of that learning process. Contractors that are familiar with installing the residential mini splits may have their way of doing things and have had really good success with it. So we just want to do a best practices system. We want them to up their game, up their level, and know that we really require a good pressure test and a good vacuum on these systems. Maybe a little bit more than what they're accustomed to doing, but that's just learning, taking something new and applying it to what you're already familiar with.
When I started to trade, we had a tool bag. We came up with gauges. We started slapping gauges on the system and started looking at everything. One of the things I thought was really different now is the diagnostics process.
Absolutely. So if you want to go through the system, we can read all of our thermistors, which are sensing our temperature and pressure, right through the 7-segment LED on the front of this. So rather than having to hook up gauges and then you've got your de minimis release through your hoses, we can actually see our high side and our low side, and we can even check our compressor temperature off of the unit and see how is our system operating. We can look at things like fan speed and then look at the charts and graphs and say, okay, are we within normal operating fan or are we running high on the fan? If our fan's overamping or running too high, we can go back and look at, okay, why? Why are we trying to move excessive air? Is our compressor too hot? Do we have a low charge? 90% of the time, that's the issue that we're looking at. So having the ability to look at that 7-segment LED and read all these different points in the system without having to hook up gauges, we really know and can get a good gauge, a good understanding of what the system is trying to do and what it's actually doing.
And there's a thermistor actually on the discharge line, and compressor overheat kills any compressor from any brand. So they're monitoring the temperature of that compressor to make sure that there's oil return. And some of these systems actually have an oil separator. They're able to separate that oil before it even goes through the whole entire system, but they're monitoring that compressor. When that temperature gets too high, it goes into safeties, it goes into retry, so it protects itself. And I noticed there's a lot of thermistors on this system, but I didn't see any thermisses on there. There's thermistors, but where are the thermisses at?
Oh, thermisses. Excellent. One of the nice things about the thermistors is when we take the service class, we actually talk about what thermistor controls what, and it tells you at what temperature we're going to begin to enter that protection mode. So we can begin to understand what the system's doing based on the temperature of that thermistor. And so each protection code has an engage at what temperature, and then it has a release. So if the system is able to correct itself, if it's a transient condition, it just solves the problem and goes away. Whereas if it's something that it can't fix and can't continue to operate, it will throw you an error code. So we can operate and monitor, and we teach the technicians how to look at what that start and stop is for those protection codes, so they know, okay, what's the safe operating parameters? Where am I at? Where should I be? And what do I need to do to get there?
Another thing I thought was cool, speaking of protections and that low ambient, it's working at -15, which is really impressive. But one of the problems that you could have is ice and moisture building up on the system. And what I thought was really cool was there was a snow mode, an ice mode that was able to actually work in reverse and do some really cool stuff that's actually shaking that ice off of there.
Sure. So on our suitcase style or horizontal discharge fans, we have a blue phenolic coating. So when the system goes into defrost mode, it actually sheds water and ice. They've upgraded some of the programming on the board for low temperature heat. They've upgraded the wires to withstand that low temperature, and there's a base pan heater in there for low temperature operation. On our vertical discharge units, we have something called snow mode. So when you live up in New England like I do and it snows frequently and it gets wet and heavy, the outdoor fan will kick on for 1 minute just to shed that snow, and then the technician gets to set the intervals. Do we want that to kick on every 10 minutes, every 20 minutes, every 30 minutes? When the ambient temperature goes below 45 degrees, snow mode is enabled, keeps that fan clean so that it can continue to operate. Once the ambient temperature goes above 45, snow mode is disabled.
It's just amazing all of the details that go into engineering this equipment and then testing it and trying it and all of the little bitty steps. I mean, there's engineering that goes into the copper and the thickness that it takes. So one of the things that I really appreciate is how engineers go through things, work together, then do field testing, and they take all of this massive amount of data and they're able to then make it to where it translates it to you, to me, to all of us together, so that we can use that data, which is a lot of work on its own. And then they're able to take the trainers and come in and like, hey, let's teach you how to use that data. So taking these classes are massively important. And this is the future of HVAC. This is the future. So some people say, hey, I don't like fuel injection. And hey, you don't have a choice anymore. Now all the cars are fuel injection. Some people say they don't like VRF. I love it. I'm a fan of it. I was way more comfortable with it now than I was when I first walked in that door. But this is the future. But you don't have to be scared of it or afraid of it. You can come in, these amazing instructors, and they have full of energy. Great class. I go to some classes, and me personally, you guys know I have ADHD, and trying to stay focused is very difficult. And this class here, it was on point. It was going massive amount of information. I think I just about drained one pen taking notes, but they made it fun and interesting. And then we got to actually do it. It wasn't just like you had to remember all of the stuff. They teach you where to find it, and you get to actually put your hands on it. Not just anywhere. They teach you exactly where to put your hands on it. Like this hands on is good, that hands on is bad.
Absolutely. So the fundamentals of any service is just sequence of operations. What should happen first, second, third? So once you know that, we just apply that to any VRF system. What's the first thing that needs to happen? What's the second thing that needs to happen? Follow that sequence of operation. Find out what it's not doing and what it should be doing, and then look at the component that controls that. And then we diagnose the component. Do I have a bad thermistor? Or am I not sending a signal off of the board? Do I have a bad board? So we diagnose, we don't just change parts.
That's it, right? We don't want to just be parts changer. One thing I thought was interesting too was you didn't just tell us, hey, this part's bad. A lot of it was about why and what that part actually was and why it was there, why that protection was in there. And I thought that was pretty awesome. You know, a lot of manufacturers, not everybody has their own reasons, but the fact that you're able to share the information of the how and the why and what that component's doing, it made me more comfortable because I'm the person asked why. Why does that happen? How does that work? And when I was growing up, I used to take all my toys apart. That how did it work? I have to know why. And I love it when people want to not only design really good systems, but also to be able to teach and show you that why and answer that curiosity that I have, and maybe you have too.
Absolutely. If a component fails, we want to know why it failed and what we can do to prevent it from failing in the future. How do we fix the problem, not just change out parts?
And most of the components, they're not just failing. There's something that caused it to happen, cause and effect. There's usually something else in there. And compressors do not die; they are murdered. So you got to find out what killed it. Let's find that culprit. Let's get that fixed, and then we solve that problem.
Absolutely.
All right, Clifton, want to take over for us?
Sure. All right. Thanks a lot, Ty. Let's all gather up front again. We're about ready to wrap up the show. And, one of the important things to talk about is you're talking about working with engineers, Ty. I think everyone should,
And not just trains, right? We're talking.
yeah, we're talking mechanical engineers. One of the things that, come on in here, guys. Our screen's a little little close on us there. You know, one of the things that we learned being here at the Fujitsu training facility is that research and development is right next door, right? So we have R&D working with technical training hand in hand. We have engineers in the technical training facility doing changes, making improvements, looking for ways to allow the systems to function better, easier access for technicians. So it's a cooperative between the technical side, us, and the engineering side, merging together to make for a fantastic training program. So we're so grateful that you all joined. You have something?
I do want to add one thing. When I'm talking about the training, the instructors, these aren't just people that are out reading a manual telling how to do it. They've been in the field. They've designed the system. They've solved these problems. There were so many stories that Juan gave us that was like, hey, this is a scenario we ran into. This is actually what happened. So it's good to know that the people you're teaching you have been where you are, that really understand it. And that's a big difference.
Yeah, I think so. All right, Juan, John, I really appreciate you having us here. We're looking forward to seeing you all at the National HVACR Education Conference. You were with us this year. We had classes. We're going to be doing some presentations. We're going to be getting to know all of our educators much closer this year. So we look forward to seeing you at the conference. Make sure that you connect with Fujitsu General. Learn about all the training classes that are available. I'll put links once I repost this. I'll have links to the training programs, how you can connect with their stage, how you can introduce VRF into your classrooms and educate your students and technicians and contractors as well. So thank you all for joining us. We'll see you all again next week on Did You Know? The ESCO HVAC Show.